All right, keeping it going here. AP stats. So last video we did discussion on 5-point summary and box plots. I have that example up here in front of us because we're going to continue to discuss this one, and we're going to talk about in this video outliers. So if you remember, and it shouldn't be hard because we have the picture right in front of us. After we constructed this box plot, you might have looked at that long whisker over here. Okay, and if you look at the data set, you see this 85 is like really far out from where the group is. So it's causing the data, we would say, to have a right skew. Now, is this data what we would consider an outlier? So an outlier is a point that's like really far out from the group, something that is not a typical value. How do we actually numerically determine that? How do we know that 85 is really far out there? Maybe it's like right on the edge of being considered really out there, because you see there's these three. Maybe these three are the outliers, in addition to the 85. Or maybe the 85 really isn't an outlier. How do I actually determine? So there is a rule of thumb for determining outliers. And that is that we would measure 1.5 times interquartile range, and we're going to subtract that. So any numbers that are less than Q1 minus 1.5 times, or greater than Q3 plus 5 times interquartile range would be labeled an outlier. So that is our concrete way, our quantitative or objective way of measuring an outlier. So we're not going to eyeball this and go, oh, I think this might be an outlier. No, we're going to actually concretely figure it out because we have the actual numbers to work with. When we don't have the numbers, then yeah, we kind of, this kind of looks really far away. I think it's an outlier. It might potentially be an outlier. We would have to look at the data to make that determination. So I'm going to grab my trusty calculator. Just you guys do this as well. And we're going to actually calculate what the cutoffs are going to be to determine what an outlier is. So first I'm going to figure out this 1.5 times IQR. So remember, IQR is going to be Q3 minus Q1. So 42.5 minus 15. So I get 27.5. Now I'm going to times that by half. Sorry, times that by 1. And I get 41.2. That's my 1.5 times. So now I'm going to take quartile 1, which is 15. If I subtract 41.25, 15 minus that answer of, and I get, so any number less than, I'll put it in green. So for us, it would be negative 26.5. And if it's greater than, so Q3 for us was at 5 plus 5. That's 83.75. Those would be considered outliers. So back to our data set. Is 85 an outlier? Yes, because it is greater than our cutoff. So this 85 is an outlier. It's going to influence the mean, meaning it's like dragging the mean further from the mean. So if we were to actually calculate the mean for this, you would see that the mean is going to be greater than the median. So it's getting pulled by that outlier. We have any outliers on the low end? The answer is no, because no number was less than 5. So no outliers on the low end. It could be possible that that happens in other data, but in this case, no. So we only have one outlier, that's at 85. So we would state it somewhere over here, 5 outlier. So you can kind of see like, okay, well, these, even though they were away from the pack, they really weren't that far away from the pack to be cause for concern to be labeling them as outliers. You may have multiple outliers in a data set. Be aware of that, that can happen. All right, so let's grab another data set and then do the same work there to kind of identify if in fact has an outlier. Okay, so here's our second data set. So I copied another one from the book, and I went ahead and I took the liberty of taking that data set and turning it into a stem and leaf plot. That way the numbers are already nicely done in order, and for us to be able to get our 5-point summary. All right, so first off, there are 21 data points in this set. So remember, in order to get our 5-point summary, we're going to need to break this up into quartiles. So again, just as a visual, I have to do this, but there are 21 numbers. So that means we're going to break this up 10, 10 with that single number being our true median. We're going to actually have a number that's in the middle. So let's go ahead and pick that already. So we see 1, 2, 5, 7, 10, 11, 12. So here's the 10th number. This would be the median right here. Our 34 is our median. I'm going to start in 1, 3. So our median. Okay, so that leaves us with 10 numbers in the first group, 10 numbers in the second group. All right, so in the 10 numbers in the first group, and we're going to split that in half. So 5, 6, so 25 and 26. That gives me 25.5 for that Q. Again, median in that pocket. Okay, now in the second pocket, now we got 1, 2, 5, 6. So 45 and 45, they happen to be the same number. So we luck out middle to figure out there. 5. Max score was 73. Our lowest. Pretty quick getting those numbers. Now, time to construct our whiskers. So I'm going to go ahead, and since I see that our minimum is 16, I'm going to start at 10, and I'm going to go in increments of 5. So 10, 5, 30. The part where you really want to make sure you're scaling appropriately, taking your time, because if this starts to get distorted, if we're not scaling it properly and measuring out where the 10 marks are supposed to go, then when it comes time for us to make our analyses, where the picture is going to look off and it's not going to make much sense to our analysis. Say, oh, it's skewed, metric, is due to us not scaling it. All right, so I'm going to use blue to indicate where my values are. 16, it's going to be somewhere like 70. My min, and my max. Again, you don't have to label it. I like to label it. I know lines or what. Median's at 34. Q1 is at 25.5. And Q3 is at 5. So these three connect together. Our box. here. Now, this is our box. And so just like when we had before, we see that there is already from the picture a skewness to the graph because whisker over here versus short whisker. The middle 50%, unlike the first one though, looks pretty symmetrical. We have just as much variability here as we. Okay, so now we're going to see, do we have any outliers present? So let's calculate quartile range. So it's going to be Q3 minus Q1, 45 minus 5.5, divide that by. So our 1.5 times IQR is 29. Now we're going to take quartile 1, subtract that number, get negative. Anything less than that would be outlier. Don't have anything like that, so no outliers on the low. What about the high end? So we'll take our 45, add 9.5, get 74. Anything higher than 74.25 would be. So this 73, even though it's way out here, and we see a gap in our data, is not technically an outlier. So we do see some skewness, but it's not what we would consider an abnormal skew. The graph is shaped with a slight skewness to it. So this helps us identify and be able to, again, describe the distribution in a more objective way versus just kind of like, oh, I'm just staring at the picture and kind of, making a judgment call on what the shape of the distribution looks like.